This screencast is about the structure of solids and some of the properties and vocab associated with different shapes within a solid. This screencast is also directed towards AP Chemistry. You can have two different types of solids as a general rule. You can have a crystalline solid or an amorphous solid. A crystalline is where everything is lined up in nice, neat rows, as shown in this image. You see the rows, and there is a pattern here for the columns, so you could follow. It has a specific defined arrangement, and it has angles. In an amorphous solid, you can see that it is very random and that you have all kinds of just placement that makes not necessarily any pattern, and there is not a specific pattern. Amorphous is the opposite of the crystals, and it has varying strength for their intermolecular forces. Crystalline typically has better intermolecular forces because the molecules are able to get near each other due to the pattern nature. Two words to be aware of when you're dealing with crystals: you can have a unit cell, which is a one complete cell for one repeating pattern. It is the simplest repeating pattern in a crystal. And then crystal lattice is the ongoing 3D structure. Now this image here on the right has something else going on inside. You can see that it has some kind of intrusion, but for the most part, the rest of the pattern is very repetitive. All right, so there are three main types of unit cells that crystals can take. So the first one is called primitive cubic, and you can see in this particular image that it looks just like the face of a die. Okay, it has six sides. It has squares connected on all the different directions. You would have an element at each corner, and they'd be ions, and there would be bonding going on there. The second structure is called body-centered cubic, and so you take that die, and you put an atom or an ion in the center, and then the remaining cubic structure that we had on the previous side now has a element in the center. So this blue dot is suspended in the middle of this particular this cube. Okay. The last one is face-centered cubic. So we have our crystal structure, again, our unit cube, and on the surface of each face you have a atom or ion. Okay, so there's one on each side, just like the numbers on dice. Each side of those cubes has 1, 2, 3, 4, 5, and 6. So the same thing is going on here. Depending on the size of your atoms in your ionic compound and the nature of it, you can have two different kinds of arrangements. You can have cubic packing, or you can have hexagonal packing. And as you can see in the two different images that I've linked here, I have this one that is, you can see the two different substances, and these look pretty similar in size. And over here in the red and green, you can see that the green is much smaller and therefore fits in between the red ones. The cubic would be the red and green, and the hexagonal would be this blue and yellow. A lot of times when you look at the grocery store and they have fruit arranged on like pyramids or rows very neatly, where one apple sits in between the two other apples below it, that is most often hexagonal close packing. And it's just how they arrange themselves in a cell or a unit cell. There are 4 different types of bonding going on in solids. The first one is in molecular solid. That would be a molecularly bonded covalent compound, and these have weak intermolecular forces. These are often soft. They have low melting and freezing points. They would be liquids or gases at room temperature because they have those low melting and boiling points. And their properties will depend on the substance. I have shown for you here a sugar cube. Sugar is a covalently bonded compound where the electrons are being shared, so it is a molecular solid. The next one is a covalent network. So this is a little bit stronger than just a molecular solid. It would have a little bit higher melting point, or a harder density, more like appearance, and I have shown you diamond. And diamond is still covalently bonded. It's all carbon, but it has arranged itself in a crystal structure that gives it a much higher IMF and a more, it has a harder physical property. Third are ionic compounds, and this is composed of ions, and this will depend on the charges. So if you have a choice between NaCl, Na is +1 and Cl is -1, and if you were comparing that with a compound of magnesium, which is +2, sorry, it's getting hard to read, Mg, which is +2, and oxygen, which is -2, the higher charged would give you a higher IMF and therefore a higher melting point. So the more, this would be a stronger IMF going on compared to NaCl, which is weaker. And that's dependent on the charges in the ions. And so I have shown you an image here. I believe that's NaCl magnified many times. The last type of bonding in solids is metallic, and this contains of metals that are closely packed together, and so the bonding, or the IMF, increases with the number of electrons that are free to float around in your metals. We don't run into metals very often in this level of chemistry. If you go on to college and you study chemistry, you may end up with a class that is inorganic chemistry, and that would be more of the focus there. So lots of things to consider when dealing with solids. You have the shapes, you have the type of cubic alignment, and then you have the different types of bonding.